In today's world, clothing is disposable. Fabrics fray, seams tear, colors fade, and most garments end up in landfills before they've truly been worn. But over 800 years ago, European artisans created textiles built to endure. These were fabrics of precision, patience, and human skill, engineered for function and beauty, designed to survive decades, sometimes even generations. No machines, no synthetic chemicals, only craft, observation, and intimate understanding of the material itself. Our journey begins with raw fleece, flax, and silk, the fibers that formed the backbone of medieval Europe. Wool, long and strong, provided warmth and resilience. Linen offered crispness and structure, but demanded months of labor to transform stalks into thread. Silk, imported at great cost, signaled status, wealth, and prestige. Each fiber had its own story, its own character, and its own role in the high medieval wardrobe. Spinning was the first stage where human mastery became apparent. The drop spindle, a simple shaft with a weight, allowed spinners to twist fibers into thread. Unlike modern machines, this process adapted to subtle variations in the fiber. Every thick or thin section was corrected by hand, producing yarn with strength, flexibility, and life. This yarn would carry the human signature through every subsequent stage: weaving, dyeing, waterproofing, and fulling. On the loom, threads were arranged with meticulous precision. Every heddle, every warp, every shed demanded attention. Patterns were woven with intention: twill, herringbone, diamond, combining utility and artistry. Dyes derived from weld, madder, and woad were fixed using minerals and temperature control, while lanolin-based waterproofing kept garments resilient against rain and cold. Fulling compressed fibers into dense, durable surfaces, and brushing created a soft, uniform nap. By the end of the process, the fabric wasn't merely clothing, it was an artifact of centuries-old craft, alive with human touch, subtle variations, and practical genius. Modern machines can replicate speed or uniformity, but never the resilience, character, or responsiveness of handcrafted medieval cloth. This journey isn't just about textiles. It's a step back into a mindset that revered quality above convenience, skill above automation, and longevity above fashion. If you want to see how medieval craftsmanship created textiles that lasted generations, subscribe, because what you're about to learn will change how you see every piece of fabric you own. Before any loom is set or dye bath prepared, the medieval textile journey begins with the fiber itself, the foundation of all craftsmanship. In high medieval Europe, three fibers dominated: wool, linen, and silk. Each required an intimate understanding of its properties, seasonal cycles, and handling methods. The quality of the final cloth depended entirely on how the raw material was prepared. Wool was the backbone of northern economies. Sheep breeds differed regionally, producing fibers with unique lengths, textures, and resilience. English wool from the Cotswolds was prized for its long, strong threads, ideal for smooth, dense fabrics. Spanish merino offered fine, soft wool suitable for luxurious garments. Preparing wool began with washing the greasy fleece in streams or wooden tubs, removing impurities without damaging the fibers. The next choice, carding or combing, determined the yarn's character. Carding teased the fibers into a light, airy bat, producing woolen yarn that trapped air for warmth and thickness. Combing aligned longer fibers and removed shorter ones, creating smooth, strong worsted yarn for fine garments and durable hose. Linen, the symbol of purity and structure, demanded patience and precision. Flax stalks were pulled by hand to preserve full length, then redded in water or on grass to separate fibers. After drying, they were broken, scutched, and heckled, producing silky threads suitable for weaving crisp fabrics. Linen required months of labor before spinning, yet its strength and smoothness rewarded the investment. Silk, imported from Byzantium and later Italy, was reserved for nobility and ceremonial garments. Its preparation was delicate, preserving the filament's integrity through careful handling. Each fiber, whether wool, linen, or silk, carried within it the potential for extraordinary durability and elegance, but only if respected and processed according to centuries of refined practice. Mastering these fibers was not about speed. It was about understanding, touch, and anticipation, knowing how each thread would behave on the spindle, the loom, and in the finished textile. Every subsequent step relied on this foundational expertise. Once fibers were prepared, the next stage transformed raw material into thread, the lifeblood of medieval textiles. This was spinning, an act that demanded both precision and intuition. In the High Middle Ages, the primary tool was the drop spindle, a simple wooden shaft with a weight at the end, deceptively minimal, yet extraordinarily effective. The spindle's weight stored rotational energy, allowing fibers to twist into strong, continuous yarn. Each flick of the fingers, each adjustment of the hand, controlled the thickness, tension, and twist of the thread. Unlike modern machinery, which enforces uniformity, the drop spindle worked in harmony with the fiber, responding to subtle variations that only a human hand could detect. The process began with drafting, carefully pulling fibers from the supply while controlling their density. Too many fibers and the yarn thickened unevenly. Too few and the thread snapped. Skilled spinners developed an instinctive feel, sensing when to adjust tension to accommodate the fiber's natural inconsistencies. This interaction produced yarn with character, subtle variations that gave the finished cloth resilience, flexibility, and life. Twist direction was equally critical. A clockwise twist, or Z-twist, or counterclockwise S-twist, determined the final yarn structure. Spinners often combined threads in plying, twisting two or more single yarns together in opposite directions to balance forces, creating durable, stable yarn capable of withstanding the rigors of weaving and daily use. Hand spinning was slow and deliberate. Producing enough yarn for a single tunic could take weeks, but speed was secondary to control. Every moment spent spinning strengthened the artisan's connection to the fiber, embedding knowledge of its behavior into every strand. Machines can replicate speed and uniformity, but they cannot reproduce the subtle responsiveness, strength, or living quality of hand-spun thread. Here, centuries of refinement and intimate understanding were embedded directly into the material itself. With hand-spun yarn ready, the next challenge was to prepare the loom, a stage that required patience, precision, and foresight. High medieval weavers often worked on horizontal frame looms with treadles, a significant advancement over earlier vertical designs. The genius of these looms lay in their heddles, each loop holding a warp thread, and foot pedals capable of lifting hundreds of threads simultaneously. But before weaving could begin, the loom had to be meticulously dressed. Warp threads were measured and arranged according to exact calculations. For a cloth 2 meters long and 60 centimeters wide, with 10 threads per centimeter, hundreds of individual threads needed to be prepared. Each thread was carefully measured for length, accounting for loom take-up and weaving waste. They were then wound onto a warping board in a precise pattern to create a cross, a critical intersection that maintained order and prevented tangling during weaving. One misstep in this stage could ruin days or weeks of work. After measurement, each thread was threaded through heddles, a painstaking task performed one by one. Alternating threads passed through different shafts, ensuring the pattern and tension were maintained. The threads then passed through the reed, a comb-like tool that spaced them evenly and allowed the weaver to beat the weft firmly into place. Once tensioned and secured to the front beam, the loom was ready, a field of potential energy waiting to be transformed. This preparation was slow and deliberate. Master guild weavers spent months perfecting the art of warping the loom. Apprentices learned that patience, precision, and respect for the material were as important as physical skill. Only with a correctly dressed loom could weaving proceed. Each row of weft building on the foundation of careful planning, human judgment, and centuries of accumulated expertise. Once the loom was fully dressed, weaving began, a rhythm that transformed individual threads into living cloth. In high medieval workshops, the process followed a precise, repetitive sequence. Shed, pick, beat. Each motion was deliberate, demanding focus and intuition from the weaver, who moved in harmony with both the loom and the fibers. The shed was created by pressing a foot treadle, lifting specific warp threads to form a triangular opening. Through this space, the shuttle carrying the weft passed. The pick followed, a swift motion of the hand sending the weft thread through the shed, leaving a line of thread that would form the fabric. Finally, the beat compressed the new weft against the previous row using a beater, a heavy wooden frame with a reed to keep threads aligned and tensioned. This percussion, the rhythmic thunk of the reed, was the sound of progress, echoing across workshops in Bruges, London, and Florence. Patterns added complexity. Twill weaves, diamond shapes, and herringbone required careful coordination of multiple shafts and threads. These weren't merely decorative, they enhanced strength, flexibility, and drape. Master weavers understood the interplay between yarn variations, tension, and weave structure. Hand-spun yarn, with its subtle thickness variations, demanded responsiveness. The weaver adjusted the beat and tension instinctively, producing cloth that machines could never replicate. Every imperfection was part of the fabric's character, a signature of human attention. The weaving process was slow but intentional. Unlike modern automated production, speed was secondary to precision. Each centimeter of cloth carried the mark of skill, the judgment of the artisan, and the subtle energy imparted by hands attuned to their materials. Through this rhythm, raw fibers became fabric, infused with resilience, warmth, and the knowledge embedded in centuries of tradition. Once the fabric was woven, the next step transformed neutral cloth into vibrant textiles. In the High Middle Ages, natural dyes were the heart of this process, turning wool, linen, or silk into colors that conveyed status, identity, and artistry. These dyes were not applied haphazardly. Each hue required precision, knowledge of plant chemistry, and careful control of time and temperature. Yellow came from weld, red from madder root, and blue from woad. Each required specific handling. Madder root, for instance, needed to be harvested at peak maturity, dried, and ground before boiling in carefully monitored baths. Too high a temperature, and the red would turn dull. Too low, and it would fail to penetrate the fibers. Woad posed an even greater challenge. Its indigo compounds were insoluble in water. Fermentation transformed them, producing a solution that would bind to the fiber. When exposed to air, the color shifted from pale green to deep, permanent blue. The entire process demanded attention over several days, with subtle adjustments in stirring, temperature, and pH levels that only experienced dyers could judge. Metal salts, or mordants, were added to fix the color and enhance durability. Iron darkened shades, copper produced greens, and alum brightened tones. Each combination produced unique results, meaning even the same plant could yield a variety of shades depending on treatment. The process was both science and art, a careful balance of chemistry, observation, and intuition. Through dyeing, the medieval textile became more than fabric. It was a living surface, rich with depth, subtle variations, and permanence. Colors were not merely decorative. They reinforced the fabric's function, signaling value and ensuring resilience. Each thread carried the marks of human expertise, chemical understanding, and tactile skill, a level of mastery that modern mass production often cannot match. In medieval Europe, textiles were meant to endure harsh weather, and artisans developed natural methods to make fabrics resistant to rain, snow, and wind. Unlike modern waterproofing, which relies on synthetic coatings, medieval methods worked in harmony with the fiber, preserving warmth, breathability, and flexibility. The key was lanolin, a waxy, water-repellent substance found naturally in wool, combined with other materials to enhance durability. Fresh lanolin was extracted from raw fleece through slow heating, producing a sticky, pale yellow substance. Left pure, it protected but could wash away quickly. To increase longevity, medieval craftsmen blended it with pine resin, beeswax, or animal fats. This mixture was applied carefully to the woven cloth, worked evenly by hand to penetrate fibers without damaging their structure. Heat was controlled precisely. Too high, and the wool became brittle. Too low, and the mixture would not bond effectively. Once treated, the cloth was stretched and allowed to cure, creating a fabric that shed water while remaining breathable. These techniques were not merely experimental. Shepherds, travelers, and sailors relied on them for survival. Cloaks kept wearers dry during storms, while sails and tents treated with similar methods endured ocean winds and mountain rains. The application was labor-intensive, demanding intimate knowledge of both material and environment. Every step required judgment. Too much wax, and the cloth stiffened. Too little, and protection failed. The results were remarkable. Treated wool maintained its insulating properties, remained supple, and offered resistance to the elements. This was a living technology, one that emphasized adaptation, balance, and responsiveness. Modern outdoor textiles, despite advanced materials, often cannot replicate this combination of performance and natural harmony. Medieval waterproofing illustrates how human skill, observation, and careful material selection produced fabrics designed to last, not just for seasons, but for generations. After weaving and waterproofing, the cloth remained relatively loose and open, strong, yet unfinished. To achieve the dense, weather-resistant fabric prized in the High Middle Ages, artisans relied on fulling, a process that compressed and interlocked fibers. Fulling transformed raw cloth into a material capable of withstanding cold, wind, and repeated use, while simultaneously refining its texture and thickness. Originally, fulling was performed by hand. Workers trampled the fabric in large tubs of warm water combined with alkaline solutions, often wood ash or potash, to clean, shrink, and strengthen the fibers. The friction caused microscopic scales on wool to interlock, creating a dense, durable surface. Over time, water-powered fulling mills were developed, using large wooden hammers to rhythmically pound the cloth, maintaining consistent pressure and freeing artisans from labor-intensive footwork. The pounding was not merely mechanical. It was controlled, deliberate, and adjusted based on fiber type, moisture, and fabric thickness. Following fulling, the cloth underwent additional finishing steps. It was stretched on tenters, wooden frames with hooks that held the fabric under tension, ensuring even dimensions. For luxurious textiles, surfaces were brushed with dried teasel heads to raise a nap, then sheared with iron shears to create a smooth, uniform finish. Multiple repetitions of this process produced surfaces as even and lustrous as velvet, highlighting the careful balance of labor, observation, and material knowledge. Each stage of fulling and finishing reflects the medieval commitment to quality. Unlike mass-produced fabric, every yard carried the touch of human judgment, adjustments to pressure, timing, and technique that machines cannot replicate. The result was a textile built to endure, dense, pliable, water-resistant, and visually rich. This final transformation ensured that cloth was not just functional, but an artifact of human skill, capable of lasting decades and carrying the signature of its maker. Medieval textiles were more than functional. They were carefully engineered works of art. Weavers did not merely create flat, uniform cloth. They incorporated patterns that enhanced strength, flexibility, and aesthetic appeal. Twill weaves, herringbone, and diamond patterns were widespread, chosen not just for decoration, but for practical advantages. Twill, for instance, created diagonal ridges that improved drape, reinforced durability, and resisted tearing, making it ideal for cloaks and outer garments exposed to harsh northern European weather. Creating these patterns demanded precise coordination. Multiple shafts controlled by heddles allowed the weaver to lift specific warp threads in sequence, while carefully measured weft threads interlaced to form the desired design. Any error could disrupt the pattern, requiring painstaking corrections. Hand-spun yarn added complexity. Subtle variations in thickness required the weaver to respond instinctively, adjusting tension and beat to maintain consistency. Modern machines cannot replicate this delicate responsiveness. They break under non-uniform threads, whereas a medieval weaver could harmonize the material's natural variations into the final design. Patterns also served a functional purpose. Diamond or herringbone arrangements distributed stress across the cloth, preventing localized wear and extending the garment's lifespan. Beyond structural considerations, complex weaving communicated status, guild affiliation, or regional style. Master weavers internalized these patterns over years of apprenticeship, understanding both the technical and symbolic dimensions of their craft. Even the simplest plain weave carried evidence of human judgment. Each warp and weft interaction reflected experience, tactile understanding, and attention to fiber behavior. Through patterning, medieval artisans elevated functional cloth into durable, adaptable, and aesthetically sophisticated textiles. Every inch bore the imprint of human skill, revealing that medieval fabric was not simply clothing. It was an engineered system designed to endure, perform, and express the ingenuity of its maker. Medieval textiles carried a signature that modern mass production cannot replicate: the human touch embedded in every thread. Hand-spun yarn contained subtle variations in thickness, twist, and texture, differences that machines today would flag as defects. Yet these variations were precisely what gave the cloth resilience, flexibility, and life. Each thread told a story of the spinner's interaction with the fiber, the skill honed through years of careful observation, and the intimate understanding of material behavior. Industrial machines prioritize speed, uniformity, and predictability. Thousands of threads are pulled at once, tensioned to rigid standards, and spun mechanically. The result is perfectly even yarn, but one stripped of responsiveness and character. In contrast, the medieval spinner responded continuously to the fiber. A thick section was gently drafted, a thin section was reinforced. Twists were adjusted to maintain strength, and plying combined opposing threads to balance forces. This produced yarn capable of stretching, compressing, and enduring stress, qualities essential for garments exposed to daily wear and harsh conditions. The interplay between human skill and fiber created fabric with a living quality. When woven, the cloth adapted to movement, temperature, and moisture. Patterns aligned naturally with the yarn's behavior, and textures shifted subtly across the surface, providing strength, comfort, and tactile richness. Imperfections were celebrated as evidence of craftsmanship rather than errors, making each piece unique, durable, and responsive to the environment. This contrast highlights why medieval textiles continue to fascinate. They were not only functional and beautiful, they were engineered to endure, with every stage reflecting thoughtful human decision-making. In an era dominated by disposability and standardization, the medieval approach offers a radical lesson. Longevity, adaptability, and material intelligence cannot be manufactured. They must be cultivated through skill, patience, and intimate knowledge.